Hello everyone. So in this video, we are going to see a transient based question. Okay. In this question, you need to find out uh, the double derivative of this inductor current at t equal to 0, or you can say at t equal to 0 plus. Okay. You need to find out it. Uh, so how to proceed this kind of question? One general approach could be you first find out the expression of I of t, and then you put t tends to 0 or 0 plus, then you will find out the like you have to put t tends to 0 or t tends to 0 plus at double derivative of I of t, right? So this is the conventional approach. You have to first solve the second order circuit, and the solution will be bit heavy, and then you have to find out the expression of it, then you have to double derivative it, and then you have to put the value of t equal to 0 plus. This is how the conventional approach says, but there is some other ways to solve this question. uh, so basically, first we will analyze the first derivative part. Okay, so let me start. Now, I just wanted to analyze the circuit at t equal to 0 plus. I wanted to analyze the circuit behavior at t equal to 0 plus. See, the inductor and capacitors are initially relaxed, so they don't have any energy before t equal to 0. So, inductor and capacitor both will try to hold their energy. Inductor will hold the energy, or it doesn't allow the sudden change of current by making the current continuity, and the same way the capacitor will also not allow the sudden change of voltage across it. That will also make the continuity in the voltage. Okay, like for inductor, the inductor current cannot be discontinuous, and for capacitor, the capacitor voltage cannot be discontinuous. So that we will see now. Okay, so let me draw the circuit first. uh, yeah, so this is 20, this is 10 ohm, and the initial inductor current was 0 ampere. So for t equal to 0 plus also, the inductor current will also be 0 ampere, and this is 2 ohm, and this is my voltage source of 0 volt. Okay, this is 2 ohm. Now the few things we can find out from here. Let's say this is my VL of 0 plus, this is my IC of 0 plus. If you try to find out what is IC of 0 plus, no current is flowing in the inductor, so entire current is basically flowing through this path. Okay, so your IC 0 plus will be 20 by 12, right? 5 by 3 ampere. And if you try to find out the VL 0 plus, this is simply the voltage that is appearing across 2 ohm. So 2 into 5 by 3. So 10 by 3 volts. Why I have calculated this two, you'll be able to know now. So for a inductor, the voltage across inductor is simply L di by dt. Now let's say I wanted to calculate the rate of change of inductor current at 0 plus. Then I need the VL 0 plus by L. So di 0 plus by dt is equals to VL 0 plus. VL 0 plus is 10 by 3, and inductance value is 2 Henry, right? So this should be di 0 plus by dt is equals to 5 by 3 ampere per seconds. Okay, so see, initially the current of the inductor will be 0, but the rate of rise of the current will not be 0, because let's say for example my inductor current is rising like exponentially. Okay, it will not be exponential, but I'm just explaining one phenomenon. So if you see the at t equal to 0, the slope of this particular current is not 0, it is making some angle with respect to positive x-axis. So that is the value that we have calculated. Okay, one can think the initial current is 0, the rate of rise of current will also be 0, but this is not the case. Okay, by the same way we will calculate IC of t is equals to C dVc by dt. So your dVc 0 plus by dt is equals to IC 0 plus by C, right? So the same way the rate of rise of the capacitor voltage at t equal to 0 plus. The IC 0 plus was 5 by 3 and the capacitor capacitance was 1 by 4. So 20 by 3 volts per second, right? This things is clear, I hope, right? Maybe you can check calculation one more time. Hmm. Now I need to find out the second derivative. So what I will do, I will I will try to draw the circuit again. This is my VC of t 2 to 10 ohm, 2 Henry, 2 ohm. This is 10 volt or 20 volt, 20 volt. Okay. Now you have to find out a relationship of this I of t with the rest of the circuit. Okay, so what I can do, the voltage that is appearing across inductor, it is VL of t, and VL of t is simply L di by dt, and we have to find out the d2I by dt square. So if I take derivative of this this equation is equals to L d2I by dt square. So to find out this quantity at t equal to 0 plus, if I can find out dvl by dt 0 plus by L, then it will be easy for us. Do we know? I know di by dt, but I don't know dvl by dt. So I have to approach in some different way. And this particular current is IC of t. So here you have to make some relationship from the circuit. C dvc by. Now if I write the KVL equations, loop equations, let's say this is my loop number 1 and this is my loop number 2. Okay, if I write the KVL in this two loop, from loop 1, from loop 1, if you write, see this current is I of t plus IC of t, right? So 20 is equals to 10 I of t plus ICT of t plus 2 di by dt, that is nothing but VL of t, right? For loop 2, we can write 2 di by dt is equals to 2 IC of t plus VCT of t, right? Yeah. So if I write 2 di by dt is equals to 2 um, ICT of t, right? ICT of t is nothing but C dVc by dt, right? So C dVc by dt, C is 1 by 4 dVct by dt plus VCT of t. So, and here also, if I write 20 is equals to 10 I of t plus 10 ICT of t plus 2 di by dt. If you take derivative, 0 is equals to 10 di by dt plus 10 uh, dict by dt plus 2 di by dt. See that dic by dt I don't know, but let me put c is equals to ic is equals to c dv by dt here. So I'll get 0 is equals to 10 di by dt plus 10, and ICT of t is nothing but C dVc by dt, and C is 1 by 4. So I'll get d2 VCT by dt square is plus 2 di by dt, right? Hmm, sorry, there is a mistake here. It will be d2y, right? Because I made two double derivative. Yeah. So if you see this particular equation, so let me uh, tell you again. So from this equation, if you just expand, you will get this. If you take derivative in first order derivative in both the side, you will get di by 10 di by dt plus 10 dic by dt plus 2 d2i by dt square, and IC of t is nothing but C dvc by dt. So we'll get these equations. Okay. So this I have these equations. At the same time, I should make one relationship from this equations and this equation. Eventually, I need to find out this term basically di by dt, d2i by dt square at d0 plus. Mm, so if I take one more derivative here, let's say 2 d2i by dt square is equals to 1 by 2 d2 vct of dt square plus dvct by dt. So let's say this is my equation number 1, this is my equation number 2. This is my equation number 1, this is my equation number 2, and what I can do, first of all, mm, I need to omit this di by dt, d2 by dt by dt square. So maybe I can put this value because I already know. Let me write down here from equation number 1. From equation number 1, 0 is equals to 10 di by dt plus 10 by 4 d2 vc by dt square plus 2 d2y by dt square, 2 d2y by, yeah, 2 d2y by dt square, and from equation 2 I have 2 d2y is equals to half d2vc by dt square plus dvc by dt. Okay, now put the values for 0 plus. If you just put the values as 0 plus, so this will be 0 plus, this should be 0 plus, and this should be 0 plus, same 0 plus, 0 plus, 0 plus. Okay, so I hope something, yeah, dvc by this value is known, and this value is also known, 5 by 3 and 20 by 3. So here from we can write 10 into di by dt at 0 plus, it is 5 by 3 plus 5 by 2 d2 vc 0 plus by dt square plus 2 d2 I. So this particular, um, we can write down, actually you can simplify it. So this value, okay, let me write this way. See, I need not require this term at all. So I can put this value from equation from this particular one. So I can write, if I multiply it, you will get 4 d2i 0 plus by dt square. I'm just multiplying both the side by 2 minus 2 dvc 0 plus by dt is equals to d2vc by 0 plus by dt square. Now put this value into this equation, so you'll get, so 0 is equals to 10 d2i di 0 plus by dt plus 10 by 4, you will get 4 d2i 0 plus by dt square minus 2 dvc 0 plus by dt plus 2 d2i 0 plus by dt square, right? I hope this particular thing is clear. and I need to find out the d2i 0 plus by dt. So 0 is equals to 10 di by dt at 0 plus is nothing but 5 by 3 plus 10 d2i 0 plus by dt square minus 20 by 4, right? 5 dbc by 0 plus dbc by dt at 0 plus is nothing but 20 by 3 plus 2 d2i 0 plus by dt square, right? So what you will get? You will get 100 by 3 minus 50 by 3 is equal to 12 d2i by dt square 0 plus. So we'll get 50 by 3 into 12 is equals d2i 0 plus by dt square. So if you just calculate this thing, you'll get 50 50 by 3 into 12. You will get 1.388. So 1.388. So yeah,